GM. Today we're going to build out a Lilypad module. Now if you're unaware of what a Lilypad module is, I would suggest going to docs.lilypad.tech and checking out the modules intro right here. Or you can go to blog.lilypadnetwork.org and check out this module builder guide, and that will give you enough context about what a module is. So let's get started. First thing we need to do is create a couple of files. We will be working with Python and Docker. So you want to go to your working directory and create a Dockerfile, a run inference script. This is where all our logic is going to be executed, a requirements.txt file for our dependencies, and we need a script to download the model to our local directory. Once we do that, open up our code editor. Every module varies on what dependencies you need, but I would say majority of them need the transformers library and torch. So we're going to add those here as dependencies, and next thing we're going to do is work on the download script. Alright, so we've got the required files created. The next thing we want to do is select a model to use. For this demo, we're going to be using a simple paraphraser model. Basically takes in a string or multiple strings and then gives alternative ways to say that. So what we want to grab is this little part of the URL. It is the uploader and the model itself. Go back to our download script, and from the transformers library we want to import the auto tokenizer. And what this does is it converts words into numerical tokens that the AI model can understand. We'll also need the auto model for sequence to sequence LM, which loads a pre-trained AI model designed for tasks like translation, text summarization, and generating new text. And then now we can get on to writing our script. So we're going to define a function called download model. And we're going to add a model name, which equals the string that we just copied. And then we're going to load the tokenizer and the model. So to do that, do tokenizer equals auto tokenizer from pre-trained, and then we pass in the model name. And same with the model itself, but this time we use the auto model for sequence to sequence. And pass in the model name. Next, we want to save those to a model directory. So how we do that is we call the save pre-trained function on each of those. And then we pass in a directory that we want to save the model to. And same with the model here. Oh. And then next, we want to call it when we run the script. If name equals main, download the model. Cool. And that is it. That is how we download the model. Let's run this script. Depending on how big your model is, this could take up to a couple of minutes. They can get quite large depending on what you're using. So just give it a second. As you can see, it's created a model directory, and we have the configs and the safe tensors files. Okay, so we've got our model stored locally over here. The next thing we want to do is flesh out our Dockerfile. Now the reason a Dockerfile is so important is because Lilypad modules run in a containerized environment. So ensuring that all of this is correct is imperative, otherwise our module won't work. So I'm going to paste a Dockerfile I already have and then run through what's happening. So we are setting up a lightweight Python environment so we can run AI inference. And then we are updating and installing the essential build tools and dependencies. Next, we set the working directory to workspace where it copies the requirement.txt dependencies and installs all of the necessary Python libraries. Then we copy the run inference script and the pre-trained model into the container. Now these 4 environment variables here are very important because they allow us to enable offline inference. Then we ensure that we are able to write to our outputs for our results, and then it sets up an entry point where it runs the inference script on startup using Python. Now that our Dockerfile has been fleshed out and configured correctly, we want to implement the logic for the Lilypad module. And to do that, we're going to use the run inference script right here. So first thing we need to do is import a couple of libraries. The OS is going to be able to retrieve our input from the CLI command when we're testing, and the JSON library is going to allow us to export our results as JSON. And then similarly to the download Python script that we worked on previously, we want to import the auto tokenizer and the auto model for sequence to sequence LM. Next, we want to declare the tokenizer and the model. So to do that, we're going to use from pre-trained and pass in the model directory, and then we do auto model for sequence to sequence LM, and same thing. Next, we want to retrieve our input text, and to do that, we use the os.getEnv function. We're going to save it as input text, and we're going to add a default fallback, just in case we forget to add while we're testing. And we'll strip it. Cool. The next thing we want to do is tokenize the input text for the model. So to do that, we're going to declare input IDs. We're going to use the tokenizer. And this is going to be what is passed to the model. So we want to paraphrase the input text. We are going to return the PyTorch tensors needed for model processing. So we'll call that PT. We want to add a max length so we can prevent excessive memory usage. And then also we want to truncate the input if it's over the max length. And then .input IDs. Next thing we want to do is generate the paraphrase text using sampling-based text generation. So for that, we declare that model.generate. We're going to pass it the previously declared input IDs. We are going to add a number of returned sequences, so the amount of options it's going to return as paraphrased alternatives. So we'll just do 3. We also want to prevent overflows, so we'll use a max length again. The doSample enables non-deterministic output generation, so we're going to set that to true. And then top K considers only the top X amount of words, which we're going to set as 50. Then we want to add some nucleus sampling. So we'll do 0.95, and then temperature. So temperature is going to control the randomness. The higher the value, the more diverse the output. Next, we want to decode the generated outputs into readable text. So to do that, we're going to use the tokenizer.decode function. Set it as output. We want to skip special tokens. And then we want to loop through it. So for put in outputs. Now we want to make sure the output directory exists, and if it doesn't, we're going to create it. So we do that using the make ders on the OS library. Pass in our expected directory, and if it exists, okay, it will still allow us to write to it. Now the final piece. So we want to save the input and the results to a JSON file. And to do that, we want to declare outputs result.json. We want to make it writable as f, and then we want to dump the JSON in there. So we'll put input text is our input text, and our paraphrases, which will be returned from the AI model, is paraphrases f, and we want to indent it by 2. Cool. So we now have a working inference script. Next thing we want to do is build the image so we can then test it locally. So for that we do docker build. We're going to tag it and call it paraphraser v1. And then we want to build all of the content. And it's built. So one thing to note, depending on what your actual model is that you're using to turn into a Lilypad module, this could take anywhere up to half an hour to build. So be mindful when you are kind of playing around with your run inference script and you want to change some things or test out some new ways to format your outputs or something. Each time you're going to have to build a new image, and it will cache a lot of it like it has done here, but it still takes some time, so just be mindful of that. Alright, let's try it. So we're going to use docker run, and then we're going to set the input text to equal, where are all the good restaurants in New York City? And I'm expecting this to give me 3 alternative ways of saying that. The next thing we want to do is declare our working directory of where the outputs should go. So we do outputs, outputs, and then we pass in the tagged image and version. And let's try it. Okay, check our outputs, and it seems to have only given us the default input text, so fun. Let's try lowercase. Oh, there we go. We have to put it in as lowercase. Okay, so it is case sensitive. So here we have set it as input text lowercase. I made a mistake because I thought it was cis uppercase, but no. So as you can see, list the good restaurants in New York City. What is your favorite restaurant in New York? Show me the best restaurants in New York. Close enough, but still paraphrased. And that is it for the logic side of things. Now we can upload this Docker image to Docker Hub and start to get it running on Lilypad. See you in the next step. So we've got our module logic containerized now, and we've given it a test. We can see that it works. The next thing we want to do is upload the image to an image repository. For this, we're going to use Docker Hub. Very simple, straightforward setup. So you want to sign in, number one, and the next thing you want to do is click create a repository. We're just going to call this paraphraser. We're going to create it. And now what we have to do is build the image, tag it, and then push it. So if you're on a Linux, all you have to do is make sure that you're logged into your Docker, which we can do here. Login succeeded. And then for a Linux, you can just run docker build tag, And here's the syntax of how you would push that. So you do username, module name, colon, and the module tag, -- push, all. And that's it. Now, if you are on a Mac, you'll have to specify the platform. So it's a little different. So what we'd have to do is do docker build x, build platform equals Linux AMD 64. We'll add the tag. So mine is pbillingsby / paraphraser. And then we're going to tag it with v1 -- push all. And now it's going to build a brand new image. We'll give it a second. As I've previously mentioned, depending on what model you're trying to turn into a Lilypad module, this can take quite some time. Alright, so after a while we've finally got our image pushed to Docker Hub, so let's go and check out if that worked correctly. Cool, we have a v1 image right here. Amazing. Everything leading up to this point of what we've previously written out, I would consider to be preparing the Lilypad module, and now we're getting into the part where we are enabling the module to be used on Lilypad. So the first thing we want to do here is create a file named lilypadmodule.json.tmpl, and I'm going to paste in this boilerplate. Essentially what this does is it instructs Lilypad how to process a specific module. No matter what module you create and upload with Lilypad, it needs to have a minimum of 6,000 RAM in the machine spec. As we come down here, you see our entry point. It's pointing to the workspace that we declared in the Dockerfile, and it's pointing to the run inference script that we created earlier. It's giving a working directory of workspace, and here's our defined environment variable. So this is when we run the command, it's going to look for input text, and it's going to default to this if there's no input. Now in our image section, we just uploaded this, so all we have to do is get the username, the image name, and the tag. And that's going to point to that specific image. So if you change this to something else and an image isn't actually uploaded to an image repository, it's not going to run the job. So very important. And then down here in the outputs, we specify we want all of our stuff to go in the outputs directory. So now what we want to do is we want to initialize a new repository, and then we want to go to GitHub, and we want to create a new repository, and it has to be public. If it's not public, Lilypad has no way to access that code base, and it can't pull anything or run a job. So make sure it's public. So we're going to create it, and now we are going to, we're just going to run all of this. We'll add it all. Oh, actually, one thing before we do this, let's just cancel that real quick, because what we need to do is add a git ignore, and we're going to put the model contents in it. It's already baked into our Docker image, so we don't need to upload that. And we don't really need the download script anymore, so we can add that too. Now we'll add it all. We'll just push it. Okay, we need to sign the commit, and push. Cool. So the next step is, what we want to do is, oh, we actually need to save that, don't we? So we want to image link, cool. Alrighty. Now, the next thing we want to do is just double check that it's all here. Cool. We've prepared and pushed our code for our Lilypad module, and there's one thing I forgot to mention. We needed to specify to use a GPU for this on the network. So In your resources section of your template file, make sure you add GPU 1. Some modules don't require a GPU to run them, the really lightweight ones, but for this one on the network, we needed the GPU. So, now that we've got that done, we want to get the latest commit. So we can either use git log and grab the top level commit here, or you can go to the repo and pull it from the repo itself. Once we have that, we're ready to run. So we do lilypad run github.com/username/module name paste the commit char. Then we want to specify the input. So ours takes in an input text. We're going to do what are some good restaurants in New York City. And then we want to add our Web3 private key because we need to pay for the transaction. So for that, we use the flag --web3-private-key. And I have mine stored in a shell. So we're going to do Web3 private key. And now we're going to run it. We'll see how we go. So a resource provider has picked up the job and they're now running the job. Depending on what module you're running, some of these can take seconds to run, some of these can take minutes. It truly just depends. So the resource provider has submitted, verified, accepted, and downloaded the results for us. So let's take a look. So we're going to open this temp directory. We're going to check our outputs, and that's what we wanted, outputs result.json. Let's pull this in here and check it out. All right, it worked. It gave us 3 alternatives to our original input. And that is how you build a Lilypad module.